Good afternoon. Konnichiwa. It's an absolute delight and pleasure to stand in front of you, to see you all, to have gained a new community of friends and family here in Japan on this very interesting topic. And it's particularly touching for us to have been recognized by the Asahi Foundation, and together with my dear friend Bill Rees, who has spent wonderful years in the early 90s being back together. It's like the band is coming back together. And also the great hero of mine, Tom Lovejoy, not just being a scientist, but having brilliant ideas and following them into execution, for example, through Debt for Nature Swap. And I cannot wait to see your presentation, Tom. And to be here with many of my friends and collaborators, including Susan Burns, with whom I started Global Footprint Network 10 years ago. And we have worked ever since on that and lost a lot of sleep over it, to be honest. And then dear friends, Katsu, colleague, Iha, and Yoshi-san Wada, who have worked with us tirelessly. It's just a great pleasure to be here with you all and the United Nations University for hosting us here. Thank you so much for being here. I start with a picture that when you look at it, you may see disaster. What I see in this picture is an incredible learning opportunity. It's the Tacoma Bridge. It sounds like a Japanese name, but actually it's a bridge close to Seattle in the United States that, without human loss, collapsed in 1937 after swinging for some time and has been studied ever since by engineers. And in fact, all engineers, all structural engineers in their first course in structural engineering are shown the movie of how this bridge collapses, how it's important for engineers to understand physics, that their decisions matter. That's why it's a learning opportunity. And that's how we approach the sustainability challenge. Because when you ask an engineer about a bridge to say, is it strong enough? They will make calculations and they will tell you perhaps there are 2 beams missing. We should add 2 more beams. And they're never asked, are you an optimist or a pessimist? Why are you so pessimistic to say 2 beams are missing? The engineer just says, I'm an engineer, 2 beams are missing. And that's how I'm going to talk about the challenge ahead. Because I'm an engineer myself originally, proud of that. I'm sure there are a lot of engineers here. Asahi Foundation is run by engineers and run very well. So the bridge I'm going to examine is the following. Not are there 2 beams missing, but why are resource limits now undermining our economic performance? But of course, with the purpose, what can we do about it? And the starting point is a very simple one, to invite you to think like farmers. I think that's probably the transformational idea, to say, if nations were characterized like farms, which ones would be true farms? Here shown as creditors or in green. Which ones have far more biocapacity in their own boundaries than what it takes to feed the population, absorb their waste, provide all the ecological services necessary to support them? And back 50 years ago, I'm just turning 50 a week from now, so I'm still in my early 40s here. That's how the world looked like. Most countries were true farms. And in just my lifetime, the world has changed quite significantly. Today, 83% of the world population lives in countries where the population consumes significantly more than what their ecosystems can regenerate. And how do we know? We know it through a very simple accounting tool, which we call ecological footprint. That just says, ultimately, life competes for space to produce a fish, and either the seal gets it or I get it, so we're in competition for that space. Space can be understood by people because we are visual, but also scientifically, I would submit, it's a very useful unit to account our demand on nature. Why? We could account in energy, but it's not that easy. The sun powers the Earth with about 175,000 terawatts, a lot of terawatts, and then get transformed in about 200 terawatts of biomass. So when we say terawatts or energy, what do we exactly mean? Or if we measure the world, as many do, there are very interesting studies on net primary productivity. How much are ecosystems producing? What's hard to measure then, when you look at the forest, is now how much is being produced and how much is removed. If we just say there's forest area, we can quite precisely say how much timber product is being generated and how much is being removed. And through that, we can have this comparison of how much do we have and how much do we use. And I think that's at the essence. Any economist or accountant would tell you, just by knowing how much money you earn, but not knowing how much you spend, that's not that useful. We need to have this comparison, demand and supply. And that's what we can do with surface. We can say, how much surface do we have that exists in the world? And then on the other hand, how much does it take to produce everything we need? And so we can compare. So the secret is a very simple one, and I'm going to tell you. It's just knowing how many tomatoes do we produce in our garden. How big is our garden? We divide that number. That's called yield. That's the only secret. There's a second slight complication you may remember from high school, that you are allowed to swap these two parts. And then the true formula is amount of resources that we use divided by the yield gives us the area necessary to provide this flow. Very simple. Like with money, it's very simple. How many yens do you get? How many yens do you spend? So it's very simple. We also use a common currency because there are different currencies in money, yens, dollars, euros, Swiss francs. We translate our numbers in one currency called global hectares, average hectares. So we can compare. For example, Germany. German surface on average is 20 times more productive than the world's surface on average. So it makes a difference how productive it is. For example, if you have just 1 hectare that is, let's say, as an example, twice as productive as world average, we would count it as 2 global hectares. And vice versa, if the hectare is not that productive, let's assume just about half, then it would only be worth half a global hectare. Very straightforward. So now, with all these principles, you can go and calculate your own footprint of anything you want. I gave you the secret. So let's come back to this idea of the world. Now we know how to measure the world as if we were farmers, and I've also given you some results. We call it a bit like a Swiss pocket knife. You can open it, and there are lots of these tools in there to see who has how much. There is a warning. It's an origami warning on top that once opened, you cannot fold it back. But it's a price well worth paying for opening it and seeing what happens. But I think the key insight from looking at this perspective is the following. That maybe we do not have a global problem. Maybe what we have is a global storm, meaning we are in a big storm in different boats. We are in a boat as a city, as an investor, as a country, as a continent, as a region. We recognize, oh, there's a hole in the boat. Oops. How do we react? would it be wise to say, I will not fix my own boat until you all get together somewhere in a convention to agree to fix your boat first? Then I will fix my boat too. Not a very wise approach. And so I would say that's probably even bigger than the market failure of climate change is the biggest policy failure, that this fundamental insight of self-interest we have not discovered yet, that we believe it's worth wasting our future while waiting for global consensus. Now, global consensus will help, but waiting for it may be too costly. So let me just show you some examples from countries I've visited over the last month, and we work with those governments, how it looks from a national perspective. So what you see on these graphs, the green line is how much Colombia here they have per person in Colombia. There's now less because there are more Colombians. The red line shows how much they're able to consume. That's the ecological footprint. Per capita hasn't changed that much in Colombia over the last 50 years. And I had a wonderful conversation with the director, one of the 5 directors of the Central Bank of Colombia. I told him biocapacity, we believe, is the currency of the 21st century. At the end of the conversation, he told me, not only that, the global hectare, it's the only currency backed up by reality. I was quite stunned by that insight because, in essence, that's true. Ecuador, neighbor country of Colombia, one most of biodiversity-rich countries, they had about 4 times more biocapacity in 1960 than they used. They have been able to increase their consumption per person, the red line going up slightly. And at the same time, I think you can see it, okay, here. The green line going down largely because of a larger population in Ecuador. Now, Ecuador being one of the first countries in South America living with an ecological deficit. When they saw this curve, they said, are you against the right to develop? They call it el derecho al desarrollo. And so clearly we said, no, we are totally for el derecho al desarrollo. But this looks like el derecho al colapso. Not so much in their interest. And indeed, they said that's true. And they now have a national goal to say we need to move out of our biocapacity deficit. It's bad for us. They did it independently of the climate negotiations. They actually launched this idea 2 weeks before independently. And it's quite interesting, and I'm not sure I'm allowed to say that at the UN university. But from the UN convention perspective, Ecuador having a low income would have been asked not to do anything about climate change, which actually in the end would be not in their self-interest. So it's interesting to kind of reverse the idea and say, what actually does it mean to live in a boat as we enter a global storm? I was in Turkey talking with the Ministry of Development and Economy, and they start to recognize that it's getting tighter, and that may have implications for the economic performance. Been in Italy, they say, wow, Italy, a G7 country, very large biocapacity deficit, shows clearly that what Mathis is talking about has nothing to do with reality. Oh, Italy being such an industrial power. So what's the cost of biocapacity deficit? And I would like to unpack that for you. First, to look at this biocapacity deficit that now Italy essentially uses 4 times more than what Italy has. And when you unpack it, you see a big part of it, the blue part, is the fossil fuel part. They have to buy from other places. They don't have the capacity to absorb in their own country. And they also need some extra food. That's how much they have. Now, what's the problem? Let's look at how much they use. That's the amount they use. And let's look at what the cost is. So the price for resources has been going down in the 20th century and has been going up in this century. So as the amount of biocapacity deficit for Italy is increasing and the cost is increasing too, when you multiply it, what you see is that while the costs were flat for Italy early on, suddenly they have skyrocketed. It's still a smaller percentage, but what it means is that the downward escalator of costs for Italy is going faster than the Italians can run up. So it's this cost, this systemic cost that is exploding in an already fragile economy. Now is Italy alone. And I show you now a graph that they said you should never show a graph with 24 graphs on one page that nobody can understand. But it's 24 European countries identified with internet codes over the last 50 years. And what you can see is that the dynamics for each country is very different. Every boat is different. It's not one slippery slope, it's different boats. Poland, Russia, UK, Switzerland, where I'm from, but 4 countries have some very similar dynamic. Spain, Portugal, Italy, and Greece all had rapid expansion of their biocapacity deficit at a time when the costs went up as well. And it's difficult for them now to pay for that increasing cost. So it's a predecessor of the cost explosion. So when we heard about, oh, sustainability is about the future, it's hitting us today. We could make the same and even stronger case about the Arab Spring. I'll be in Beirut a month from now where we launch an Arab-wide report where the numbers look even more dramatic. That's why we asked this theoretical question. Looking at planets in general, what happens when an infinite growth economy runs into a finite planet? And the secret answer is given here. You'll find copies for you outside. But the one key answer is this. It has economic consequences. It does strain societies. We are tempted to overuse resources even more aggressively. And indeed, for more and more people in the world, it is hard to even have 2 meals a day. Now, how is the situation in Asia? And I just wanted to show a variety of different dynamics and to show again how different situations can be. Vietnam is quite impressive, how Vietnam has been able to increase biocapacity per person. Trends are not fate. You can change these trends if you pay attention. We have Japan on a quite high level, but flattening out on a per person perspective. South Korea, very rapid increase. We can also see economic crises. China, very rapid increase at a lower level, about 2, with more than 2 global hectares per person right now. So large differences, different choices. But we're all on the same storm. Now let me give you a tool to better understand how to think about the link between these resource stories and our economic performance, and why I have invoked the name of global auction. Let's start with a traditional view of how we look at the world. We say income is what we need to focus on, because with more income, I can resolve more problems, buy more food, more health, or more shelter. So it's really important to track. It's really important to track where my income is. And we add to that perspective and say, as engineers, we like locomotives, and we know locomotives, without energy, they don't run. Even a beautiful locomotive doesn't run without resources. So let's see how many resources it takes to run this economy. Do they have the resources at home or not? And when we apply this and look at how countries have moved in this space over the last 30 years, that's the graph we get.